Hello and welcome back to the Dr. Racket channel. Today I want to show you, as short as possible, that you can make quite easily, with a little effort, yourself an own GUI for your program. And I will start to show you this in a small example I made. So let's start this and I can show you how this works. You can see I have a frame, I have a text field where I can enter a name. For example, I take my name. Here I placed a message just to tell the user what happens. And here's an output window, and here's a button where I can click Start. And when I click Start, what the program does is it gives me all the permutations of my commands that are possible. And you can see these are quite a lot. This is just a simple example to show you an easy GUI made of text messages, of text fields where you can input text as data, and output windows where you can place some text, and you also have the possibility to scroll them, and you also have a button to get this whole thing in action. So that's a very easy example, and what is behind the hood in Dr. Racket is the Racket Graphic User Interface Toolkit, and I'm going to show you this now. Okay, I want to encourage you to take the Dr. Racket documentation, which is also available as PDF, and I will show you this in a few seconds, directly on the IDE itself. To take this documentation as the base of your work, because the documentation really is excellent. It's really made an excellent way. It covers everything you need to know. It's well written and also has the aim of good understanding. And of course, there's also a separate documentation available for the Dr. Racket Graphical Interface Toolkit. And this describes a toolkit that enables you to engage all those GUI stuff you know from all kind of software, where you have your button fields and combo fields and check boxes and canvases and spin boxes and stuff like that. All this you can do with the Dr. Racket Graphical Interface Toolkit, and this is made object-oriented. So all this is split down into classes, like you can see here on this page, covering the window classes. And you can see all those stuff here is inherited from a base class named area. In the next level you get sub areas, windows, container classes, and after some forking you can see here all those controls, you know, like messages, buttons, checkboxes, sliders, and
Okay, so layout managing, what is it all about? Layout managing means you made up your mind about what you want to do when you make a screen and how to place elements on the screen, where and which elements you want to place to get a surface that's convenient for the user. Okay, so let's start. Let's think this is your screen. On the screen you want to place a text field at the top of the window. And you say, okay, below this text field I want to place an output window, a canvas output window, to get to display some process text, for example. I can enter text here and I can show the process text here. And I want to use a start button placed here to get all this thing in action. Okay, after you made this arrangement, your first intention might be to keep all those elements on the fixed place where you have placed them originally. Because this is your setup and you want to keep it neat and clean. But what happens when you keep those fixed positions and the window is resized? It is enlarged or shrinked. So let's think about what happens when the window is enlarged. When the window is enlarged, you get something like this. if the origin of the screen coordinates of your window are in the top left corner, you will get something like this. And this is not what you want to have. To keep the surface beautiful, you expect from a process called layout management to rearrange all your GUI stuff, all your gadgets in a way that the integrity of your GUI stays the same. For example, it could become something like this. That looks better. And even more better it would be if this window would resize alongside with this main window here. Because this is the most important window. It has to take a lot of text, and so it would be nice if it would resize on the line parallel alongside with this main window. And the process that manages this behavior is called layout management. The layout management in TheRacket works in a way that you can specify in a container frame. That's for example, a normal frame is also a container frame because it can contain child elements, how to place them. For example, you can say, okay, my dear container frame, please arrange all your elements, if it's possible, on the top left corner. So when the first element, this text here, would be placed here. The second element would be placed beneath this first one. But because there is not enough space here, the layout manager puts it downside in this place. And when you want to get this button here, it would be placed hopefully somewhere here. And you can also do some fine-tuning. You can say if it's placing is more oriented to the middle or to the bottom or to the top. There are some screws you can turn to get this layout managing process more effective. But as your GUI becomes more and more complex, you need some kind of breaking down your layout into sub-layouts. For example, you might want that this output window and this button here should always be aligned horizontally. When you keep the layout managing process just done by this frame window, this outer frame window, this won't work because this becomes too complicated. So you can get some help from a process named horizontal panes or vertical panes. These are invisible container elements where you can put something in just to arrange them vertically or horizontally. So if you want to do this right here in our example, you could place some kind of frame around those two elements here, around the canvas output and also around the button. And if the window is shrinking or is growing, this layout here, this sub-layout here, will always stay the same. And if your layout becomes more complicated, you can do more horizontal frames oriented, for example, vertically and enclosed in a vertical pane. And this vertical pane also could be enclosed in some other horizontal pane. So you can divide all your layout, all your structure into substructures. And by using those container elements, horizontal and vertical panes, the integrity of your layout will always stay the same. And it doesn't matter if the window gets smaller or bigger, the integrity of your window will always stay the same. And you can specify, as I told you before, which elements should grow and shrink with the resizing window and which not.
And now by taking a closer look in the documentation, for example, for the GUI element frame, you can see all those parameters I just told you. You can apply a label, you can width and height, stuff like that is not so important. But as I told you, you have also these alignment parameters. With alignment, you can apply constants. You can see here, these are examples or specification of what kind of constants you can apply. You can apply left, center, right, or top, center, bottom. That means you can tell the frame how to organize its child elements in the horizontal and vertical way. For example, when you say I use left and top, then everything in this gadget is tried to be arranged on the top left, and the leftover space is filled consecutively on the right side and then down to the bottom side. And you can also specify if this object should shrink or grow with a surrounding container element by setting these parameters, stretchable width and stretchable height, to true or to false. I'm going to show you how my program works, and it's very simple. At first you have to apply the require racket GUI command here. This is necessary to import the GUI library of Dr. Racket, so you can get access to all those functions I just showed you. This is just a command. Okay, and now here the main window is generated. I use the define statement and a variable name which is named my window, and now you can see I'm instantiating a new frame class by using the new operator. And here you can see the parameterization parameters I used. For example, permutations of your name is the string here that is written in the top of the window. The width and height are obvious, and I use a style named full screen button. This is the style of the window and also specifies which elements are visible here and not. And I use alignment left top. This is a normal way. That means that this frame will try to arrange all those childs first on the top left position and then going over to the right and then going down to the bottom. Okay. The next element here is the text field, which is this one here, where you can enter your name. And now something very important happens here. You have to apply which is the parent of your window, because this text field here is contained in this frame here. We have to apply the name of the frame, which is my window here, as a parent. This is very important. Otherwise the alignment functions would not work in Dr. Racket. And then I can also apply a label. This is this text here you can see in front of the text field. I have a min and width specification, and of course we can apply a margin. That is some space that is left on the right and on the left and on the top and of the bottom side to make look the arrangement more beautiful. And you can see I also set those stretchable width and height elements to the width to true and the height to false. It means when I enlarge the window, this text will grow horizontally but not vertically. And this is something I can show you now, and you see it works. This window, this text field grows horizontally but not vertically. Okay. Then we have a message, which is this text line here. Also have to apply my window as a parent, and the label is the text is written here. There's nothing special about it. Then I took advantage of the mechanism I showed you a few seconds ago by applying a horizontal pane. The horizontal pane is something that encloses those two elements here, this canvas window and this button here. I specify this horizontal pane and also have to tell the system that the parent is this frame here, my window. I applied a margin on the left, on the right, and button on the top, and I made it stretchable in all directions, because when this window enlarges, then this content also should be able to enlarge. And this is not possible if the enclosing pane is not able to enlarge itself. And now you can see I I'm instantiating a new editor window, which is this one here. And now, for the parent, I'm not applying the my window frame, I'm applying the panel, the horizontal panel I just made. So I tell the system, this window here, or this canvas box, is part of this invisible horizontal pane that is also part of this frame. And yes, last but not least, I'm also making this button here. This button also is part of the panel, of course, and has a label which is start. You can see the start. And it also has a margin on all sides, and here you can see a callback function that is called. A callback function is something that gets kicked into action when we press the button with our mouse, when we click on it with our mouse. And you can see it's something that's called lambda. Lambda is, let's say, the body of a function you can instantiate in Dr. Racket. That is something that comes from Lisp. That means we are applying a function body here. That is, function is called in the moment when we are clicking this button with a mouse. And we have two parameters that are provided by the system. There's the button element itself, the identification of the button element, and the event. In our case, we do not need them because we just call a function we have written ourselves called doPermutation, and we use as a parameter the input of this text field here, and we get the input of this text field by sending a message to it, and this is done by the command send. Send is used to send a message, and we take the name of this text field, which is name input, this is the variable name, as a recipient for the message, and we tell it that the message is get value. That means essentially we are sending a message to this input field that tells it, please give me your input, your text input, provide me your text input. And this is what is returned here by calling the function between those two parentheses. And this is taken as an input for our function doPermutation. And we're applying the variable text output, which is the identifier of this text output window, also to our function, because when it has done all those permutations, then the result is displayed on this canvas window here. Okay, the last story to tell you is how these permutations are done. In this function, you can see I implemented a loop with two loop parameters. The first one is a list, the second one is a text. So what I'm essentially doing here is that the string, the original string of the name that is placed here in the text parameter of this function, is converted to downcase by this string downcase command, and I'm ensuring with this piece of code here that this string cannot be longer than 8 characters. The reason why I'm doing this is because I experienced that the permutations done on strings that are longer than 8 parameters really can get your system down on its knees, and therefore I applied this, let's say, this fuse. So I cut away everything that's longer than 8 characters and throw it away, so the string cannot be longer than 8 characters. And then by this command string to list, all those characters are converted into list elements. I'm doing this because there's a command existing in Racket, named permutations, that does all those permutations automatically for you, but it needs to take its parameters as list elements. So for this reason I'm converting the string to a list, and all those permutations, all those big stuff is stored in this list parameter named LST. And the second loop parameter here is named txt, and it's a text. A text is an object which is needed because our output window, the text output window, the editor canvas, is quite abstract in its behavior. So it's not dealing with strings directly, it's dealing with text objects that also have attributes like fonts and size and color and stuff like that. Therefore we have to instantiate a new text object, and it also has a parameter named auto-wrap. That means it's obvious that the lines are wrapped automatically when the string is reaching the right border of this canvas window. Well, as you know, every loop needs conditionals, otherwise it couldn't be terminated. And for this reason I placed this const statement here, and it's asking if the list of permutations is already empty. If it's empty, then I send to this text object, or insert in this text object, a string named permutations done. This is the string you hopefully have seen at the end of the editor canvas window. If the string is not yet processed completely, then this else fork here is active, and what's happening here is that I send the current permutation, which I take from the start of the list by the char command. Char means give me the first element from the list, which is one of the permutation. This element, as I told you, is made of single characters. It's not a string yet, and therefore we use the command list to string to rearrange these character elements to a compact string again. And this string is inserted in our text object. And then I insert a new line so that the next permutation is printed in a new line. And then the loop is starting over again by taking the first element from the list away and processing the rest of it. And when everything is done, the complete filled text element is sent with the send message to the out parameter, and the out parameter is an identifier for our text output window here. And the command we use in this message is set editor. That means that our text output window now knows that the editor text it has to use is this one here, and from this moment on the text is displayed. And last but not least, very important thing, when all this stuff is done here, all this GUI arrangement and building, then we have to use this command here, send my window show. As you know, my window is our main frame here, the frame that contains everything of our GUI, and it has to be made visible by sending a command to it that tells him please show yourself, and this is done by setting the show parameter to true. Okay, I hope you learned a little bit about doing GUI stuff in Dr. Racket, and I hope I will see you again in my next video.